Okay, so this is a continuation video from the previous video where we discussed about Baeyer Villiger oxidation, its mechanism in all possible reagents under acidic or basic media, Lewis acid mediated Baeyer Villiger oxidation, and we solved lots of practice problems keeping the entrance exam in our mind. So now let's talk about the Baeyer Villiger oxidation in Bornyl and non-Bornyl system. So you might encounter this kind of ketone in your exams, and you might ask to draw the product when this kind of system is subjected to Baeyer Villiger oxidation. So there are four possibilities which I'm going to discuss all of them in detail. So the first one is when you have two hydrogens present here. The second case can be when you have a methyl group in the left side and hydrogen in the right side. The third case can be we have to do exactly opposite, methyl in the right side and hydrogen in the left side. And the fourth case can be where we have both the side methyl group. So these are the four possibilities for this Bornyl system. So let's say I am reacting this with a Grignard reagent which gives me R minus, and this R minus is going to attack at this carbonyl system. So in first case, we see we have two hydrogen here which will not cause any hindrance, and this carbonyl is a planar molecule. So just because we have two hydrogens here, this R minus can comfortably come from above the plane and attack at this carbonyl and breaking this bond. So this will give me so we have two hydrogens and R group is present above the plane and OH is below the plane. So you have to imagine this carbonyl is a planar molecule. So this is my plane and R group is above the plane. It is attacking from above the plane simply because the hydrogens are not capable enough to do hindrance. Let's see the second case. So in second case, once again the R minus can comfortably attack from above the plane because it is approaching from right side, and at right side we have hydrogen. So that's why once again the R will be up, OH will be down. Here we have hydrogen and here we have methyl. Let's see the third case. So this time R minus can attack from here and it can attack from below the plane. So it cannot approach from this side because this time in the right side we have a methyl group that will do the hindrance. So that's why the R minus will attack at this planar carbonyl from below the plane, and the product will be so this time R is attacking from below the plane, so R will come down and this bond will break and OH will be up. Similarly, the fourth case, the methyl group present at the right side will not allow the R minus to come from right side, then it has to come from below the plane and the product will be we have a methyl, R is coming from down and OH will be up. So this is a basic which you need to know before I move on in the next slide. Okay, so let's discuss the Baeyer Villiger oxidation for all the cases with mechanism. So the first case when we have two hydrogens in the system. So here we have hydrogen and a carbonyl group. Let's say I'm using hydrogen peroxide for my Baeyer Villiger oxidation. For detailed mechanism, please refer to my previous video on Baeyer Villiger oxidation. So what do you think? What is the product for this particular reaction? Feel free to pause the video and try the mechanism and find out the product. Okay, so let me redraw. So we have a hydrogen peroxide and we have hydrogen in the right side that is not capable enough to do hindrance. So this oxygen will comfortably attack at this planar carbonyl group from above the plane, breaking this bond. So we have two hydrogens. We have O minus below the plane. And we have this oxygen above the plane in this particular system. Now we have to migrate a particular bond. We have to migrate either this bond or this bond towards this oxygen, and then this whole group is going to leave. So which bond should I migrate? A or B? What do you think? So always remember, so take a note that whenever you are doing migration of a particular bond, it has to be anti or the trans. Okay? For example, if I draw this particular bond, let's say this one I'm drawing 1, 2, 3. So it looks like 1, 2, 3. Right? Let me draw this one 1, 2, 3. So it looks like 1, 2, 3. So what do you think? Which is a anti bond? Clearly this one. So these are completely opposite to each other, a trans system. So this is how a trans bond will look like. You have to remember this. So this oxygen will form a double bond. Okay, so this is a trans system. So this particular bond will migrate towards this oxygen and this whole group is going to leave. And you generate. So this time oxygen will be inserted here because this group or this bond has migrated. So I am going to insert my oxygen here. And this is the product for this particular reaction. So I simply inserted my oxygen here. Okay, let's discuss the second case. So here we have methyl in the left side and hydrogen in the right side, and we have a carbonyl. And I'm doing Baeyer Villiger oxidation using hydrogen peroxide. So this time, pause the video, draw the mechanism, and find out the product. Whether oxygen will be inserted from here or from here. So let's do it. So we have a methyl here and hydrogen in the right side. We have a carbonyl. H2O2 can comfortably attack from right side because hydrogen is present in the right side, and this bond is going to break. So this will give me methyl here, hydrogen here. O minus is going to be below the plane. We have OOH. Now this is my anti position. So this is my anti position. So this oxygen will reform a double bond. This bond is going to migrate and this bond is going to break. So the product will be this one. So we inserted oxygen here. Okay, now let's see the third case. Where we have methyl in the right side. So pause the video, draw the mechanism and find out the product. So this is my carbonyl, this is my methyl present in the right side this time, and hydrogen peroxide. So this time the oxygen is not going to attack from above the plane simply because methyl is present here to block it. So this oxygen will now attack from below the plane, breaking this bond. So this one give me methyl in the right side, hydrogen in the left side. This time we have this whole group present below the plane. So this is O, O, H, and this O minus is above the plane. Right? Now here we have two cases. First, this is clearly a cis, okay? So if I draw this particular system here, I have to migrate either this bond or this bond, this one. So if I draw, let's say A, B, C, D, so this is how it is looking. This is clearly a cis bond or the cis fashion. But look here, a type of trans bond or the anti-position bond is present here. So that's why this oxygen will form a double bond and this particular bond will migrate to oxygen, leaving this OH group. So the product will be this one, this one. So this time we are inserting oxygen from this side. Okay, so here's the last a type of question you might encounter in your exam. So we have two methyl groups and we are doing Baeyer Villiger oxidation. So what is the product? So the oxygen will be inserted from here, just like the previous question, because the attack will happen from below the plane. Okay, so mechanistically, two methyl groups, a carbonyl. Attack will happen from below the plane because methyl will not allow it to come from above the plane. And this is giving me, so O minus will be up because attack has happened from below the plane. Right? Now this is a cis conformation, but the bond will migrate from the trans conformation. So that's why this oxygen will reform a double bond and this particular bond will migrate towards oxygen, removing OH. And this will give me, let me draw the product here. So I'm going to insert my oxygen from this side. And this is the product. So this is the product for this particular reaction. Okay, so let's conclude. The first case, two hydrogens and a carbonyl. Then we have second case, methyl in the left, hydrogen in the right, carbonyl, the third case, and the fourth one. Now this methyl can be any R group or any alkyl group. Okay. So this is the first one, this is the second, this is my third one, and this is the fourth one. So let's do m-cpba, or the hydrogen peroxide mediated Baeyer Villiger oxidation for all of them, and let's write the product for all of them. So the hydrogen is in the right side, so attack will happen from above the plane. Here attack will happen from above the plane because still we have hydrogen in the right side. But the moment we have methyl group in the right side, the attack will happen from below the plane. And here the attacking species is oxygen from hydrogen peroxide. So we are attacking by oxygen. Okay. And whenever you are attacking from above the plane, the overall product will be oxygen inserting from the opposite side. So I'm attacking from this side, so oxygen will be inserted from this side. I'm attacking from this side, so oxygen will be inserted from this side. I'm attacking from below the plane, so oxygen will be inserted here from above side, and similarly for this one. So the product will be for all of them. So this is for the first one. Okay, this is for the second one. This is for the third one. And this is for the fourth one. Okay, so that is for today, and do share with your friends. Thank you.